Whoa, hey guys, just shopping around through all the different stuff that is available to us that I access anyway, and I pulled up this RAM B slider, which I'll put the links below. It's coloradostate.edu. But what it is, it's the GOES 16 satellite, goes east, and this is just giving you a full disk of the natural color of the Earth as the sun moves across. Now, whoa, check that out down here at the bottom. So here's the US. So just after it gets dark across this whole face of the Earth, this big, huge object comes by across the bottom. And you can see they tried to pixelate it out, but that thing's pretty big. Let me see if I can pause this thing. Not sure if I can. Well, I could slow the speed down. Whoa. So, things keep getting stranger and stranger. And this would be being captured by satellites that, the GOES satellites, they're all in a geosynchronous orbit, which is 22,236 miles above the Earth. And this is the latest run I pulled up on ISWA, last 300 frames. And there's the Folk radiation belts. I mean, nothing too crazy has been happening apart from what's the craziness we've been seeing. See all the polar cap black field lines that normally just stream away like that, but they become closed to ward off this extra pressure that's coming from the backside. That's when they become red. You can see they're closing and going way out to this is Earth radii here. These increments, each one's roughly 4,000 miles, 3,959. So you could see these closed field lines are extended well beyond 400,000 miles in order to ward off all this backside pressure that you see coming in from Nemesis. And as I mentioned before, our sun emits mostly protons. Nemesis emits mostly electrons, being the equal opposite rule discovered way back in around Newton's time, Newtonian physics. And so these are all electrons, and these Folk radiation belts, they measure electrons coming in around the Earth, and particularly inside this geosynchronous 22,236 mile orbit. So as you can see, we got a ton of electron energy bathing the planet continually. These are the slowest moving electrons, 10, measured at 10 keV. So they're low energy electrons, and these are the highest high energy electrons, which are zipping around pretty fast apparently, and they're measured at a level of 4,000 keV or 4 MeV. So anyway, we had some missing time here. The only missing time was between the 18 to 22, other than maybe 20, 30 seconds here and there. So who knows what they're covering up there, but we did have a big chunk missing from the 1800 to the 2200. See here, 1815, 1831, 1835, then it comes to 2245. So we got 4 hours missing there. So something pretty calamitous happened that they don't want us to see there. So I'm just going to sync this back up. I didn't see any huge anomalies from the solar wind speed, but I didn't look at it super close. Well, let's run through it real quick. Solar wind speed. Now this is all being measured inside this by these GOES satellites, which is measuring stuff that's inside the magnetopause and inside the 22,236 mile orbit circumference that they go around. And you can see there's nothing too crazy going on there. Oops. 1044. Okay. So I'll let them play through, get them sync back up. But this is the kicker here. This huge object. Let's see if we can determine the circumference of it. Ooh, there it goes. It looks pretty big. Not as big as the Earth maybe in circumference, but it's pretty big. Now most people would say that that's impossible. How could something that big be that close to the Earth? But I'm going to show you, and I put these links under most of my videos. I wish you guys would access them. But anyway, here we got it here. Once the Nemesis system gets in the front of the Sun simulator, and the cloaking is gone, it's over. Well, and the Sun simulator is between 700 800 kilometers above the Earth. So this could still be what we're seeing here on the RAM slider could still be, and I'm sure it is, above the 700 800 kilometer heliosynchronous orbit of the Sun simulator. And that's where you click on that link and it shows you the types of orbits which they're able to park things at and maintain that particular altitude and inclination without expending any fuel. And here's the Sun synchronous orbit. That's what I'm talking about. So that's where the Sun simulator has to be parked, around 700 800 kilometers, in order for it to maintain an orbit right in front of the Sun. And basically obscure a lot of stuff. And as I mentioned before, there's the geosynchronous orbit, and it's giving you it's giving it to you in kilometers, 35,790, which I did the math a long time ago. But here you can see, if you just Google kilometer to miles, 1 kilometer equals 0.621371 miles, and I just did the math on the calculator. It comes out to 22,238.868 miles. So that's the geosynchronous orbit. Yeah, okay, I'm sorry. Running out of time already. We're at the 9-minute mark. So anyway, there's the geosynchronous orbit. So back to my point. Then people think that a planet, if that were that close to the Earth, it would be causing huge deleterious effects due to gravity upon the planet. But that isn't true, because gravity is a much lesser force compared to electromagnetism, as much as 10 to the minus 40th power less. So the electromagnetic forces from Nemesis, our binary twin sun, that's going to be the cause of the predicted likely pole shift, not gravity. And I think, as I showed you before, that we've reached this equilibrium, and Earth is pretty much caught between Nemesis and our sun. some kind of an electromagnetic equilibrium now, and I'm going to show you that again, but here it is. Gravity 10 to the minus 40th power. So there could easily be a big planet down here, and if you Google receding oceans, I don't know if you're aware of that, but we've had some definite things that could be linked to gravity with receding oceans at different times. Let's see. Okay, and as I showed you yesterday for the first time, it's not the first time I saw it, but it's the first time that I saw it at such a extended period of time, and this thing runs for like 3 hours and 30-minute increments. It's from the University of Michigan. It's a geospace model. It's on the SWPC NOAA site. And here it is again. So this is the last 3 hours. This is UTC, so take 5 off of that for Eastern Daylight Time. So it started around 4 a.m. this run, 4 something a.m. And it's going up to, you can see here the pressure. We got that pressure equalization again, which really that did not happen before if you've been watching any of these recent videos. And the pressure is indicated by color coding, and as you can see, the coding is down here almost next to 0 or even less than 0. But I think that there's 0, and I think then we have different, I don't know how it could be negative pressure, but maybe, I don't know. I'm not exactly sure, but anyway, normally it's real red over here and real red all around the planet, indicating high pressure from solar wind coming from the sun and from Nemesis. And just yesterday, this thing has reached some type of an equilibrium. But if you look at the density, you can see that even that there may be an equilibrium in pressure, but that means all this stuff's being stacked up in here, and we got a lot of density. So there's a lot of density showing there. So here's what I think it's going to look like when this thing finally gets below the 700, 800 kilometer range. And this is a video with Mishu Kaku and Chris Hadfield, the ISS astronaut, and they're driving around yucking it up, and then there's big planets are popping into view around the Earth, close to the Earth. So, and I think they're having such a good time. So anyway, that's predictive programming there, in my humble opinion.
Would you want to go to Mars? Oh, absolutely.
Yeah, I want to go to Mars. Absolutely not. And as I showed you yesterday, we don't have that big gap anymore around, which used to start around 2200 hours and extend all the way up to 0600 hours. Huge gap. So that tells me that something has definitely crossed the plane. Crossed the plane of the Lagrange point. I don't have time to pull that up because you can see I'm running out of time here. Anyway, open up these links below my videos. The Day of the Lord's quickly approaching. I did a search on the Day of the Lord in Bible Concordance. You can see how many verses are mentioning the Day of the Lord. And I would contend that it's not far away, guys. Not far away. This is going to be the biggest thing to happen to this planet in 3,600 years. Ever, really, because Jesus said in Matthew 24:21, "For then shall there be great tribulation, such as was not seen since the beginning of the world to this time, no, nor ever shall be." So I'm running out of time. God bless, peace, and I'm out.